Okay, so chapter 16 wraps up our unit on probability. It deals with probability models. There are two different probability models, and we've actually looked at these probabilities before. We're just going to look at some of the cases that are easier to do once we use this model instead of like writing the whole thing out. So we talked about two different types of probabilities. One is a geometric model. A geometric probability is we are going to keep trying until we get our first success. So we have one success on that last try. Maybe we are shooting a basket. And how many baskets until we get that first shot? Or what's the probability that the first one we make is on our 5th attempt? We've done probabilities like that. We've written it all out. Now we're going to have a shortcut model to use for that. Okay. And then the second one is called a binomial model, where you are picking, say, out of 5 attempts, what's the probability of making 3 of them? What's the probability of making at least 3 of them? In chapter 14, we dealt with the probability of at least 1. And somebody asked, well, what if it's a probability of at least 2? And I said, wait, we'll do that later. This is where if it's a probability of at least 2, or at most 2, we'll use a probability model to get that probability instead of having to write everything out. Okay. So, but in order to use our probability models, they must be what's called a Bernoulli trial. These 3 things have to be true in order to use these. There has to be 2 distinct outcomes described as success and failure. Now, if you're talking about rolling a die has 6 outcomes, but if you're only interested in rolling that 5, then 5 is a success and everything else is a failure. Well, that's if I'm rolling the die. It has to have a fixed probability of success for each trial. Okay. The probability can't change from one to the next. At one point, I believe we did a problem where we did a simulation in chapter 10 about taking the driver's test. And the first attempt on the driver's test had a 34% chance of passing, but a second attempt was a 72% chance of passing. So because that probability changed, it would not be considered a Bernoulli trial. The outcome or the probability has to be the same every time. So we call P the probability of success and Q, 1 minus P, the probability of failure. P plus Q will always add to 1. Okay. And there has to be independence from trial to trial. If you're rolling a die, if you're shooting a basket, if you're bowling, each trial should be independent. If they're not, say you're pulling from a bag of M&Ms, okay, and you need to have less than 10% of the population to be your sample, and then the probability doesn't change enough for that to matter. So we'll first talk about a geometric probability model. It's the number of trials till you get your first success. The probability of getting your first head on the 5th flip. The probability of getting your first strike in the 4th frame. Bowling. It has a mean or expected value of 1 divided by the probability of success. The standard deviation of this model is the square root of Q divided by P squared. We very rarely use the standard deviation for this. And the equation, the probability, is the probability of failure, Q, to the x minus 1 power times the probability of success. If I'm talking about the first head being on the 5th flip, I have 4 failures and 1 success, right? That's why it's x minus 1. I'm going to get 4 failures and 1 success. If my first strike is in the 3rd frame, I have 2 failures to get that strike, and the 3rd one is the success. So I have 1 success, and everything subsequently is a failure. Okay. So here's some examples. A new sales gimmick has 30% of M&Ms covered with speckles. These groovy candies are mixed randomly with the normal candies as they are put into bags for distribution and sale. You buy a bag, remove candies one at a time looking for the speckles. What's the probability that the first speckled one we see is the fourth candy we get from the bag? Let's think back to probability from chapter 14. How would we do that? Give it a try. All right, so the fourth candy is the first speckled. So what does that mean about the first three? They're not speckled. So in this case, we'll identify P as 0.3, right? The probability of success getting that speckled candy, which means Q is 1 minus P, 0.7, right? So it's 0.7 to the third times 0.3. The last candy is speckled. We get 0.1029. Very similarly, what is the probability that the first speckled candy is the 10th one? So how many failures do I have before my first success? 9. So 0.7 to the 9th times 0.3 is 0.0121. So this is what we did in chapter 14. Okay? But here's where it gets a little different. What's the probability that we find the first speckled one among the first three we look at? When it says among the first three, that means it's either the first candy, or it's the second candy, or it's the third. So I have to calculate three different things. So what's the probability that the speckled one is the first one? 0.3, right? It's the first candy, or means we're going to add or multiply. Add. Or it's the second candy we see. So the first candy is not, and the second candy is speckled. Or it's the third one we see, 0.7 squared times 0.3. So that word among means we're going to actually add up that it's either the first candy or the second candy or the third candy. And we're still talking about it being the first one being on that one attempt. So let's add that up. 0.3 plus 0.7 times 0.3 plus 0.7 squared times 0.3. I got 0.657. Is that what you got? Okay. And the last question is asking how many do we expect to check on average to find our first speckled one? Expect on average means the mean, right? When you see how many do we expect on average, expected value is the mean. The mean of the geometric distribution is 1 divided by p, which is 1 divided by 0.3, 3.33. So we expect on average to have to check 3.3 candies before we get that first speckled one. Okay, so this basketball player makes 80% of his foul shots. Assuming the shots are independent, what's the probability he misses the first time on his 5th attempt? What does that look like? How many makes? 4 makes. What's the probability he makes it? 0.8 to the 4th times 0.2, right? What do we get? 0.089. 819. 8192. Okay, what's the probability he makes his first basket on the 4th shot? That means he missed what? 3. So 0.2 to the 3rd times 0.8, which is what?
0.0064.
And then he makes his first basket on one of his first 3 shots. So that means he makes the first one, right? So 0.8. Or, means add, he misses it and makes his first one on the second. So misses and then makes. Or he misses the first 2 and makes the third one, right? And that adds up to 0.992. Okay. Now, I think I'll give you the calculator command now. Yay, there's a calculator shortcut. Okay. Calculator shortcut, there are 2. Geomet, PDF and Geomet CDF. Actually, I might be just Geom. Go ahead and look in your second VARS menu, back in your distribution menu where we have our normal CDF. And if you go up, the last 2, in our calculator, I go second, VARS, and if I go up, it takes me to the bottom of the list, and I have 2 commands. Second, VARS, which is where your normal CDF is. I go up to get to the bottom of the list. You're welcome to go all the way down if you'd like, but I have Geomet PDF and Geomet CDF. Okay. PDF stands for point density function, point meaning a single value. Okay. So this is a single value. And CDF stands for cumulative, meaning it adds up the values up to the number you give it. So for the first problem, he misses the first attempt, okay, on, his first miss is on the 5th attempt. The P, the probability of success here, is actually missing it, right? So the calculator is asking for what is the probability of what you want, P, that's 0.2, and what trial do you want it on? We want it on the 5th attempt, right? So if I put in 2 and 5 and paste in my calculator, or to show my work, I would write Geomet PDF 0.2, 5. That's your P and your X. And then hit enter, and we got the same answer. Okay. This again is in your second VARS, and it's at the bottom. It was E and F, or F and G, something like that. Okay. Can you use this command to see if you can get the same answer as you did in the second one? His first make is on his 4th attempt. What will your P be in that case? Your P will be 0.8. So it should be Geomet PDF 0.8, 4. And you should get the same answer. Same thing we got. Okay. Now the last one is the CDF, where I want to add up 1, 2 to 3. So I go back into my second VARS, and I go up to G. It's F and G, not E. Okay. My probability is a success, 0.8. And I want it among the first 3 attempts, so X is 3. And the calculator adds up X of 1, X of 2, and X of 3, And we get the same answer. 0.83. So we have these calculator shortcuts that will do the work for us, which is really nice, especially with the cumulative ones. For geometric, the single ones aren't real bad, right? They're pretty easy. But if I wanted to know what's the probability his first miss is among his first 10 shots, I don't really want to do that by hand, right? Let's think about that. His first miss, so he misses his first basket among the first 10 attempts. You'd have to add the probability that he misses it on the first attempt, plus the probability he misses the second and the third. And you'd have to add up 10 different probabilities. Okay. The calculator command lets us do geomet CDF, missing it 0.2, comma, 10. And it does all those calculations and adds it up for us. If his first miss is among one of those first 10 attempts. So he either missed it on the first attempt, or he makes it but misses his second attempt, or he makes the first 2 and misses his third attempt, all the way up to he makes his first 9 and misses his 10th attempt. We don't want to do that by hand, and the calculator has the command that does that for us. And once again, showing your work is close to just putting all of this in, okay? One thing you need to do is identify, in order to use the calculator commands, for the problem, so for each problem you would have to identify P is 0.2 in this case. In this one you have to identify P is 0.8. Right, because it's a little bit different, and you have to identify it as geometric. So you need to say geometric with a P of 0.2 or geometric with a P of 0.8, and then you can use the calculator commands, and that's counted as showing your work, not plugging anything into the lengthy formulas. Okay, questions? Now, the other probability model is a binomial model. A binomial model has a fixed number of successes or fixed number of trials, and that is n, and you have a certain number of successes in those trials. What's the probability of getting exactly 3 heads in 5 flips? Your n is 5, your x is 3. What's the probability of getting 6 strikes in 10 frames? That's binomial. The order in which that happens does not matter. I can get it anywhere in those 6. I can get anywhere in those 10 frames, which allows for a lot of different combinations. Okay? The geomet will save you some time. The binomial saves you even more. Okay? The binomial command. The mean for the binomial model is the expected value is the number of trials times the probability. If you had 100 flips of a coin, you expect 50 of them to be heads, right? Because the probability of a heads is 50. If you had 60 rolls of a die, you expect 10 of them to be a 5. Because the probability is 1/6, right? The standard deviation, which we do use because the binomial model can be approximated with a normal model, the square root of n times p times q. Now when you look at your formula sheets use 1 minus p. It's just longer to say and to write. So we call q 1 minus p. So if you look on your formula sheets, which I will be giving you soon, you'll notice it has 1 minus p in place of our q. Okay. So the probability model for binomial is n choose x. That's the NCX. In your calculator, it's NCR, which is that factorial calculation. How many combinations of 5 heads are there if I flip it 8 times? That's what the nx in the parentheses gives us. Remember that our calculator does that for us. This is what it's calculating. You will never have to use that actual formula. You're going to use the calculator command that's in math, probability, NCR. Okay. And even then, we're probably not going to use that much because we're going to use the binomial CDF and PDF commands. Okay. So it's the n choose x, the probability of success to the number of successes, power, times the probability of failure to the number of failures. If there is 10 trials and 6 successes, how many failures are there? 10 trials, 6 successes, how many failures are there? There's 4, right? That's all these numbers and mean, right? If your n is 10, your 2 exponents must add to 10. X is the number of successes. This will have the number of failures as your exponent. So we can often estimate the using the normal model to estimate the binomial model. To do that, a certain condition has to be true. We have to expect at least 10 successes and 10 failures. That's NP is greater than or equal to 10 and NQ is greater than or equal to 10. And we'll worry about that in a little bit. So we're back to talking about the 30% speckled M&Ms. What's the probability we find 2 speckled M&Ms in a handful of 5 candies? Okay, we have a set number of trials, which is 5. That makes it binomial. Okay, so this is binomial with 5 trials and a probability of 0.3. We've defined our model. So we write 5, 3. Nope, I did it again. 5, 2. We have 2 successes. Okay, that's exactly what I did first period. I put 3. I don't know why. But there's 2 successes because what's the probability we find 2 speckled ones out of 5? That's going to tell us how many combinations, how many ways we can get 2 out of 5, times the probability of a speckled one. The exponent is how many speckled ones are we going to find? 2. The probability of it not being speckled. How many not speckled will there be? 3. Okay. Now there's a lot of value in understanding the formula and how to plug the numbers into the formula. Because on the AP exam, you are allowed your calculator on both free response and multiple choice portions. Calculus students do not get their calculator on the multiple choice portion, only on the free response. Okay? But they word the questions so that you don't always get to just plug stuff into the calculator and spit out a number. You will find a multiple choice question like this, and it gives you 4 different ways to plug the numbers into the formula. You have to recognize the formula and which one has the numbers plugged in correctly. So it's important that we understand the formulas and how to use them, how to write it in the formulas, because we're going to be choosing the correct ones in multiple choice questions. And there will be some like that on our test. So you get experience with that. So how does that look when we plug it into a calculator? Okay. We're not going to do the shortcut for binomial yet. Okay. Well, you don't have homework on chapter 16 tonight. Tonight's homework is on chapter 15 still. We'll finish the PowerPoint, and then tomorrow's homework will be on chapter 16. Okay. So you're not doing this stuff yet. So if you go to math, over to probability, we're going to go down to, I'm trying to get it to focus. So again, math over to probability, prob, down to NCR. I cannot get it to focus. And then some calculators will have little subscripts and some will not. So this one does, so I'm going to put a 5 and a 2. That's the parentheses part. Okay? The parentheses 5-2 is this NCR. Let's see if I can get it to focus. It doesn't want to focus on this. And then we're going to put 0.3 to the 2 times 0.7 to the 3. And we get 0.3087. Did anybody's calculator not give them the subscripts? No? Okay. You just put the 5 and the 2 in front. It'll type the NCR. If you ever have to use one of the black graphing calculators, it doesn't have that command. So you just put the 5 in front. It'll say NCR. You put the 2 after it. Then you can hit times the rest of your numbers. Okay. So can you try the second one? What's the probability that we'll find 5 speckled ones and a handful of 8 candies? Okay, so for the second one, we have binom 8.3. So 8, choose 5. That's how we say that, 8, choose 5. 0.3, how many successes? 5. 0.7, how many failures? 3. And then in the calculator, why can't I get this to focus? Focus the damn camera. Okay, there we go. Finally. What the heck is it doing? We're going to do math, probability again, down to NCR. And it's 8, choose 5, times 0.3 to the 5th, times 0.7 to the 3rd, 0.04667. Okay. So that was 0.04668. And then we'll stop with the next one. What's the probability we find at least 1? We learned in the first chapter, at least 1 is 1 minus the probability of none. So that's 1 minus 0.7 to the 5th out of 5 candies. 0.832. And tomorrow, hey, this was a question we got in chapter 14. Well, what if it says at least 2? How do we do that? We'll talk about that tomorrow. Okay. Tonight's homework is on chapter